Welcome to this educational video. The topic will be software design patterns. Reuse in software engineering. Reuse in code level is very common in software development. We can use the same code to solve different programs. For example, standard libraries in the C language, such as math.h or slim.h, can be used and reused in many programs and in the same program. Or we can use user-defined libraries like bank.h, library.h. These libraries has to be defined by the programmer. But what about reusing all designs for the programs, not just the code? Studies in other disciplines are helpful in software engineering, apart from computer science, its basic discipline. For example, an architect can use the same design for multiple buildings. Studies in object-oriented engineering field found that design patterns can be formulated to classes and objects, can be used as solutions to commonly occurring problems. Design patterns can be used as solutions to commonly occurring design tasks. Object-oriented designs and not code in specific programming language. Design should be represented as an abstract and should be explained with examples. And then abstract design is mapped to a concrete problem. We can use various kinds of design patterns, like creational, structural, or behavioral designs. Describing a design pattern, we need to specify the generic problem that is to be solved. That is, we need to identify what is exactly needed from the design. And then we need to motivate the design pattern formulation with the help of examples from other designs. And then we have to make a structure for the needed pattern. And then we have to discuss the collaborations between classes. That is how classes and objects in the programs will interact between each other. And then we need to study other issues that are related to the pattern design, such as trade-off or implementation techniques related to each programming language. And then we need to specify some description for the pattern, such as pattern name and its classification. By classification we mean, is it a creational pattern, structural pattern, or a behavioral pattern? And then we identify the intent, that is the goal behind the design, and the motivation for the design, and the applicability for the pattern design for future solutions. And then we identify structure for the design, classes will be participating in the design, and collaboration and sample code. And then we identify the consequences, that is the limitations or the drawbacks for the design, things the design cannot do or will do with limited use. And implementations, that is a programming language relevant details, and a sample code. Known uses for the design. It has to be usable somewhere else in other problems. And related patterns. We need to classify the patterns of the design. There is the creational patterns. Its main concern is how to create objects. And structural patterns. It's concerned about the composition of objects and their classes. Behavioral patterns. It is concerned about ways which objects interact with each other. Here we have some examples of the creational patterns. The singleton patterns is to create only one instance of a class. That means we can create several objects of the same class, but these objects are unchangeable. We can use them as is. Prototype to create objects by cloning an existing object. That is how we use an existing object and copy it to create a new object. The build-out pattern. The builder pattern. Build an object from an existing representation. What we mean by this is that we create an object from an existing object of a different class. Factory method differs instantiation to subclasses. That is, we can use the same object for different problems. In other words, we have polymorphism. Abstract factory. It provides an interface to create different families of an object without specifying the concrete classes of the object. And here we have an example of a structural patterns. An adapter pattern. It converts an interface to another interface. A composite. It composes an object in a tree substructure. The decorator pattern. It allows us to dynamically attach additional responsibilities to the design pattern. Proxy pattern. It provides a surrogate or placeholder for another object. A facet pattern. It provides a uniform interface to set of interfaces in a subsystem. A bridge pattern. It decouples an abstraction from implementation. Let them vary independently. That is, both abstractions and implementations can vary independently of each other. Here we have the behavioral patterns. Template method. Let certain step in a subclass be defined by the subclass itself. A strategy pattern. It encapsulates a family of algorithms and makes them interchangeable between each other. The iterator. It provides an accessors for iterating over the elements of an aggregation. Observer. If one object changes status, let its dependents be notified automatically. State. Allow an object to alter its behavior when it changes its status. In a graphical editor, we can obtain a copy of an object by simply clicking on that object. But obtaining a copy of an existing object is a common design problem in online compositions. We can provide a design solution to solve this problem and reuse the design whenever a similar problem arises. Adapter patterns. We need to build a class of hierarchy for collection of classes, like first in, first out, set, last in, first out. And then we find out that there is an existing class called stack, which can be used for providing operations like last in, first out. We can simply adapt the operations from the existing class for use for the new class. I give an example for the composite patterns is a graphic document that is composed of graphical objects like lines, rectangles, circles, text, images, and so on. Thus, the graphic document is a tree-structured composition. And for the strategy patterns, we can use different algorithms at different times. For example, a document is composed of text. Various line-breaking algorithms can be used for formatting the document before printing it. We can use these algorithms based on our need. We can consider one of the following strategies, like a simple compose. It determines the line breaks one line at a time. A paracomposer. It considers the lines in an entire paragraph. An array composer. Each row has a fixed number of letters, which cannot be exceeded. Thank you for listening.